Assalamualaikum warahmatullahi wabarakatuh. My name is LUQMAN and I'm from 4B KGS1. The direct torque control DTC algorithm is based on the error between the reference and estimated values of torque and flux. DTC is a new technique for controlling PWM inversion powered OM motor drives. DTC control is an emerging process. Without complex control algorithms, it enables a precise and quick IM flow and torque control. It also requires the knowledge of stator resistance in principle. And that's the definition of DTC.
Assalamualaikum warahmatullahi taala wabarakatuh. So today I will be representing the advantage DTC of induction motor using flexi drive. So before that, my name is Syed Muhammad bin RUSLAN. I'm from 4B KGS2. So the advantages of DTC of induction motor using flexi drive is number one, satisfy the needs for accurate and rapid motor flux and torque control. Number two, reduction in the complexity of the field-oriented control algorithms. Number three, absence of a change coordinate. Number four, absence of voltage modulator block as well as other controllers such as PID for flux and torque. Number five, minimum response time of torque, much better than vector control. So there are more advantages and application that I can state which is the induction motor has multivariable strong coupling, nonlinear and time varying characteristic. Number two, to achieve a high IM control performance, decrease the variation in the torque and flux by applying the DTC.
Now we will discuss the principal control of torque and flux. Based on the equation as shown in slide, the variation of stator flux depends on the stator voltage vector and the ohmic drop is very small in practical situation, then it can be neglected. In previous explanation, the resultant voltage will form a circle in DQ frame, and the circle is divided into 6 vectors with each is 60 degree. In each vector, there consists of 2 active vectors used to control flux. For example, in sector 3, V3 is used to increase the stator flux because the direction of V3 is outward from circle, while the V4 is used to decrease the stator flux because the direction of V4 is downward to circle. The diagram from slide clearly shows the change of flux in DQ frame. If the stator flux point is below the reference stator flux, they will generate a positive flux error when the stator flux compared with reference flux. This flux error status will show 1 means to increase the stator flux. The stator flux will increase if the stator flux point is above the reference stator flux. They will generate a negative flux error when the stator flux compared with reference flux. The flux error status will show 0 means to decrease the stator flux, then the stator flux will decrease. Zigzag type waveform will form a circle with which represent the change of stator flux in DQ frame. Now we will discuss the selection of suitable voltage vector in direct torque control of induction motor. From practical situation, the selection of the suitable voltage vector is based on the stator flux error status and the torque error status in different sector. For example, when the stator flux error show 1 and torque error status show 1, and we choose the sector is sector 3. Then the suitable voltage vector is V3. From the practical situation, when we increase the hysteresis band, the zigzag waveform in circle will become significant.
Now we will proceed to inner control operation of DTC control system for the induction motor against sudden change in load torque. This is a stimulated situation through oscilloscope where the induction machine change from lower torque to higher torque. Based on the oscilloscope, the first line would be representing the output torque of the induction motor. The second and the third line would be representing the error torque signal after and before passing through the hysteresis comparator. And the last line would be representing the D-frame voltage of the induction motor. Based on the oscilloscope, the D-frame voltage signal of the induction motor is similar to a sine wave. After zooming up the result, we will notice change in error torque signal during the rising interval of the output torque. The third line on the oscilloscope, error torque signal, would overshoot shortly before fall to its nominal value. It would result a larger duty cycle or switching signal for the induction motor. At higher output torque, the width of the duty cycle and D-frame voltage signal in contouring the induction motor has increased. It is done to maintain the output torque of the induction motor. In this session, we will observe the effect of sudden change in torque toward three-phase current supplied to the induction motor. Based on the oscilloscope, the first signal on the top representing the torque produced by the induction motor, while the three bottom signal representing three-phase current of the induction motor. Initially, the torque of the induction motor is set to 1 Newton meter. The three-phase current of the induction motor has lower amplitude. When it is suddenly increased to 3 Newton meter, we can observe that the cycle of the current increase. Other than that, the amplitude of the current also increased. As a result, the induction motor has higher rotating speed. Although DTC control system is a voltage control based system, however, it shows effect toward current when the amplitude of the torque change.